what we have done so far, we showed that the conditional statement P then Q is equivalent to not P or Q. We use the table to basically show that left-hand side and right-hand side are equivalent to each other. Now the question is, how do I find the negation of the implication? If I ask you to find the negation of P, then Q, how do you write it down? What is this equivalent to? So in this example, we're going to go over that. We can write down the negation of P then Q as P and not Q. But how that happens? Take a look. We know that P then Q is equivalent to not P or Q. So if I try to find the negation of the left-hand side, it means that I'm trying to find the negation of the right-hand side. Not P or Q. But De Morgan's law tells us that, hey, the negation of A or B is equivalent to negation of A and negation of B. This is by De Morgan's law. So take a look at this. Here we are basically distributing the negation over parentheses and everything will be affected. So this is equivalent to not P and not Q. But double negation says not P is P. So you end up with P and not Q. So again, the use of these statements is where we try to simplify some mathematical statements. They're very useful to go from left to right or right to left. We're going to write the negations for each of the following statements. The very first statement says, if my car is in the repair shop, then I cannot get to class. So in order to write down the negation of this statement, we're going to use what we learned so far. We know that P, then Q, is equivalent to not P or Q. And we also learned that the negation of P, then Q, is equivalent to P and not Q. All you need to do is to identify the hypothesis and the conclusion. So if my car is in the repair shop, my car is in the repair shop is going to be your P, then I cannot get to class. Then you have Q. Well, in order to write down the negation of this statement, you just need to copy down P, which is my car is in the repair shop and I can get into the class. For example, you can take the bus, correct? Let us write this down. The negation is going to be my car is in the repair shop and the negation of I can't is going to be I can get to class. Let's take a look at another example together. If Sarah lives in Athens, then she lives in Greece. So what's the negation here? Here we have P, Sarah lives in Athens, then she lives in Greece. She lives in Greece is going to be your Q. So for B, again, in order to write down the negation, all you need to do is follow the logical equivalent to a P and not Q. Your P, you're just going to copy down Sarah lives in Athens. And remember that when you are doing the negation of implication, you end up with and. Not Q. She doesn't live in Greece. And she does not live in Greece. Let's move on to more definitions, and we're going to go over more examples as well. When you have implication, you can define other terminology. You can basically construct some new compound statements. The contrapositive of a conditional statement of the form if P, then Q can be written as if not P, then not Q. So this is called the contrapositive. P, then Q is your logical statement implication. Its contrapositive is not Q, then not P. We have other definitions as well. The converse is if Q, then P. And we can write it this way. So you have a logical statement, implication, P, then Q. Its contrapositive is not Q, then not P. Its converse is Q, then P. Other than converse, we have inverse as well. The inverse of P, then Q is not P, then not Q. So please memorize these. Later on when we're practicing, we're going to ask you to write down the inverse, converse, or contrapositive of different types of statements. Let's go over an example. If Howard can swim across the lake, then Howard can swim to the island. Let's identify P and Q. Howard can swim across the lake is P, the hypothesis. Howard can swim to the island is Q, your conclusion, correct? So for example, I try to write down the contrapositive of this statement. Remember that if you have P, then Q, you get the contrapositive, which is not Q, then not P. You can also write down the converse, which by definition is Q, then P, and you also have the inverse, which is written as not P, then not Q. So for the contrapositive, which we know it's not Q, then not P. It means that if Howard cannot swim to the island, then Howard cannot swim across the lake. Then Howard cannot swim across the lake. So it is the contrapositive. Later on, we're going to show that P then Q is equivalent to not Q, then not P. What about the converse? So if I ask you to write down the converse, Converse is clear, Q, then P. So you're just going to write down, if Howard can swim to the island, then Howard can swim across the lake. And for the inverse, not P, then not Q. So for the inverse part of it, we know that it is not P, then not Q. So not P, if Howard cannot swim across the lake, then Howard cannot swim to the island. So that's how we write down the contrapositive, converse, and inverse of implication. As I mentioned before, the important part for you is to notice that P then Q is equivalent to not Q then not P. We use this in mathematical proof. The purpose of introducing these logical statements and their equivalence is to use them in proving statements.